So welcome guys, welcome to the webinar from on computer vision using OpenCV from Indian Society for Technical Education VIT. So guys, can you tell me, am I audible right now? Hello guys, can you tell me, am I audible right now? Yeah, so it's like I can see a couple of yes here in the chat. So it's like in this webinar, what we'll be starting with setting up Python and OpenCV library into our systems. Most of the people must have a Python in their system, but still, if anybody don't have, then the link is the link to download the Python is in the description there. You can go and download that Python link. Python, we'll be using 3.6 version of Python in this webinar. Okay guys, we'll wait for a minute, like for a couple of minutes till like some people can join. Till then, I'll be showing you what we'll be preparing in this webinar. We'll be preparing a virtual background using Python and OpenCV. It's like, I guess my screen is visible to everyone here. You can see we can even tune this background according to our convenience. So if any of your friend is still wanna come for this webinar, just give them a ping so that they can attend this. We'll be starting in a couple of minutes. Guys, then you can, till then this webinar is hosted by ISTE Indian Society for Technical Education VIT. You can go to us, you can even have a see our website. We usually conduct lots of tech related webinars and all the events regarding tech. So just tune into our Insta handle and Facebook handles. Follow us for more contents. Guys, if any of you have any issue regarding downloading the Python, do let me know in the chat. I'm looking at the chat right now. Anyone? So good to go. We are starting with our webinar. So in this, as we have already have installed Python in our systems, so now we are proceeding to how to set up the OpenCV environment into our systems. For that, we need to open command prompt in our system. So in command prompt we have to install this OpenCV library. So for Windows user we have to do it pip install OpenCV Python, and for Mac users you have to do it pip 3 install OpenCV Python. So this will install this whole the OpenCV library which we'll be using in this whole webinar into our systems, and then we'll be good to go. So guys, this OpenCV Python is already installed in my computer. So it's showing this requirement already is satisfied. In your this will be loading. So now with OpenCV Python, we'll be even requiring some of its helping libraries, which will be Numpy and Matplotlib. So we'll be even installing that into our systems. We already know that Numpy, yeah, so this is also already installed. So now we have installed all the libraries which we'll be requiring in this webinar. So now we are starting with the code part. Just guys, tell me know if anybody is still yet stuck with this Python download, because we are going to start with Python, start working on Python. Okay, so no one. So yes, we are starting with Python. Now to open ideally, we'll be searching ideally. We'll be opening. So our first program will be how to open and write images using OpenCV. So how to open and read images using OpenCV. In this we'll be using basic functions of OpenCV, like it will be just a two-liner. So to start with, before we start working on this Python ideally, I request like all of you to go into options and configure ideally, as this by like it will help us with the autocomplete of the functions, that will like, so that we don't have to memorize every function to it. So as you can see, there is an option called completions pop-up wait. Just reduce that timer to a very less amount, so that like it automatically pops up these suggestions which could help us with the recommended suggestions. This will even help us coding fast into this library. Yeah, so I have set it as 5. Now we'll be starting with importing this library into our ideally. So we'll be using import cv2. Just to check whether it is installed correctly into our system or not, we'll be saving this, and to run there is a shortcut, write F5. So I'll be naming this file as intro to cv2.py. Save. If we have correctly installed this library into our systems, so we'll be not getting any errors. Otherwise we have to troubleshoot that errors, anything which we'll be getting. So I hope nobody is getting any type of error into while doing this. If anybody is facing some error, do let me know in the chat. So see, like we are till now we haven't getted any error, so we are good to go, as our OpenCV library is all completely installed in our system without any error. Now, so for to load any image into our system using OpenCV, what we have to do is we have to first define an image, that let it be img, and the function to load any image is cv2.imread. Give the name of any image which you wanna read right now, which you wanna show. I have it as home.png. Yeah, before writing this name of your image, do make sure that that image folder, that image is in the same folder in which you are working on. As you guys can see, I have this. Just a sec. Yeah, just make sure that in the same folder you are saving this your files into, in which you already have those pictures. So I am saving it in the same. I'm just changing the name. Now let it be webinar.py. Okay, I'm opening a new file. So we'll be importing all those stuffs. Import cv2, control s. Yeah, so now this time make sure that it's in the, now we are into the same directory in which we have our images and we are even working on. So now I'm doing intro cv2.py. Now just run it again. Yeah, so there is no error. So I'm just, yeah. So here I am again. Define your image cv2.imread. See, now I am getting autocomplete suggestions. So for this I have to give the file name, the file which I want to read. So as you can see, I have this home.jpg into the same folder. So I'll be going with this same image. Now I have to show this image. So for this I have, what is this function? It is cv2.imShow. Now we are having two arguments here. First is window name and another one is our image, that is mat. So for window name, the window name is the image which will be shown in the window. So let it be image and then img. Now it's a good practice that after every function we write, after our code we write wait key and cv2 dot destroy all windows. As this will, after completion of our work, this will automatically terminate, this will help us terminating this this window in which we are working on. So see, now we are able to get our image. For see, I'll be even showing the original image to you. This is the image which we got. See, this is the home.jpg which is stored in the picture in the system, and this is image as it's exactly same. So now we can even have the we can even load this into different scales. It's like for grayscale we have to write an image in the cv2.im image. We have to give another argument, that is 0. What this will do, this will load our image into grayscale. See, this is loading now. Now we are getting our image into grayscale, and to make it colored we can even give it as -1 or keep it blank. Both are going to be same. Now see, this is the like basic function of OpenCV. Now, but the thing is, if we even only want to do this image load and all these stuffs, so what is computer vision? We already know that computer vision is a very vast topic. So what actually computer vision was initially in 1996, it was actually a group project of 10 people. It was a summer project, and which was mainly aiming at how to identify the objects. Later it like expanded, and like it's now having some of the basic like typical tasks, wide range tasks, that is instance segmentation, image classification, object detection, and object tracking. We are like right now we are very working on this object detection and object tracking, and it's still like we are using this in auto driven car and all those stuffs. Now in this webinar what we'll be focusing on is this instance segmentation. We'll be finding out where our concerned object is, and we'll be like using different functions of OpenCV, which we'll learn later. We'll be finding out where it is in its surrounding argument. Now there could be many more libraries supporting computer vision. So why OpenCV? OpenCV is because it's a very vast library. It has almost 2500 optimized algorithms, and another benefit of it is it has cross-platform interfaces. As now we are working on Python, but we can even use OpenCV in C++, Java, and various other platforms. So now in this we have various color schemes in our OpenCV. What are those? Like we already know that we have RGB. We mainly use RGB, but the other color schemes are HSV, BGR, which OpenCV actually uses. The color scheme which actually OpenCV uses is BGR. So we'll show this how OpenCV uses BGR as a color scheme by a example. So here, now I am just deleting all these codes. You will be getting all those codes in our GitHub repo. So after the webinar, so you can go there and if you have any doubt, you can refer that. Now we'll be importing OpenCV. We'll be importing Numpy into this program. So import Numpy as NP. NP will make our work a lot more easier. So now NP and import from matplotlib. The another library which we loaded was matplotlib. So from matplotlib import pyplot. We'll be using a segment of it, pyplot as plt. Now we have to again define our image, that is image is equals to cv2.im read home.jpg image cv2.im show image and img. And now this is what we learned in our previous program. Now we'll see what's the difference when we load this image from matplotlib. So for that we have to give it as pyplot. So plt dot im show img and plt dot show. Control S F5. There's some error, just a second. Yeah, so from matplotlib, let's see what is the error in this code. We are not getting this pyplot images. Let's try it again. Yeah, see, now we are getting it. This is the image which we loaded using OpenCV, and this is the image which we got as a pyplot. Just a second. Yeah, so that is actually problem between BGR and RGB color schemes which we use. You can see we are loading the same image here, but we are getting different images. It's all because of BGR to RGB format. Now, as you can see in this code, I have used img1. I have defined image 1 as cv2.cvt color. What does this function cvt color do? It actually converts the color from what, a color RGB to BGR. I don't know why the initial code didn't run. Yeah, so I'll show you how to convert this. I will be showing that image 1 as cv2.cvt color cv2. Now I am getting the arguments as source and code. Source is our image and the code is this cv2.cvt rgb to bgr. What is actually it? It's a like predefined predefined OpenCV codes which we use to convert this color schemes. So it's GB to BGR. So now let's see if this code works, or I have to shift to that code. Typo error. So yeah, take care of this typo because this naming in OpenCV is not very regular here. You can see it's I don't know, there's still some error in it, but like if we show in this This was the initial image, and now you can see that we are having the same images. Because there's some typo. Yeah. Again, what happened? Yeah, so now like after a long some errors, now we are getting the same code, same image for both the thing, and we have even got to know about this convert color function of OpenCV. Now the other thing which the other project which we are going to do is the object detection part using OpenCV. In this we'll be, till now if anybody have any error, just please tell me in the chat. I'm looking at the chat right now. Like any problem or any error till now? Yeah, Aditya Narayan, are you giving this name and everything right? Like if is your image which you are trying to load is in the same folder or same directory in which you are working on? If you are using Jupyter Notebook, then in the same project file? Okay, so no issues. Yeah, no issues. So like let's move further. Now we are going to step into object detection part. So just I'm deleting all these stuffs. Now to object detection, initially we have to define our image, that is cv2.imread. Now this time I am going to use different image for, like, it's a much colorful image, so I'll be using that to make you understand much more better about the colors. Yeah, now cv2.named window. What is this named window is? This named window is the window in which will include all our track bars and our image. So I am naming this as image, or like better it be track bar, no issues, it's just a name. So now I am going to create track bars using cv2 program. So how to do it? That's cv2.create track bar. As you can guys see that it is requiring arguments like track bar name, window name, value. So we'll be giving any track bar name, let it be like as it is. So like give it as B. Now window name, we already named our window as track bar, so we'll be giving the same name to it. Value, the value is till like the initial point of our from which the track bar will initiate, or the initial value of our track bar. So I am making it as 0, and the count the total number of points on it. Now on change is actually a function which the cv2.trackbar will initiate. So before that we need to define our function. I am defining it as, let it be callback, and as this will have a point like a location of our track bar, so it will have an argument called x. As it's not going to do anything, it's just like it's as it's asking, that's why. So we are giving it as pass the function of our definition of a function. So now we are giving it as callback. Now we have created our first track bar, just as we'll be requiring 6 of it for HSBGR thing. So I'm just copying and pasting of it. Just change it as B, G and R. Yeah. So now we are getting into the loop, because every time this change, we don't want our window to get closed. So now the else of our function will be in the loop. Let it be while loop, while true, as we don't actually require any. Yeah. So while true, what we need to do is we have to get this image, like this, the position of our track bar. So the function of it is cv2 dot get track bar, position. So the arguments which it takes is track bar name and window name. We have already given it as G, B, and window name is our track bar. Now this location, this position also needs to be saved in a variable. So we are giving it as B, as it saves the position of track bar B. Now it's in the same way we are declaring the variables G and R for track bar G and track bar R. Guys, if you have any doubt regarding this, do let us know. Do let me know in the chat. Okay. Before this, let's just know that why we are importing this numpy into our every code. So what does numpy do? Numpy is a library for which is predominantly used as for array. So just like we even using numpy we can create images. I'll show you how. Okay, let's just define img as numpy image at first. So numpy dot array, sorry, numpy dot zeros. What does zeros do? Zeros is actually like in cv2 we have colors as binaries. 0 is for blacks and white, ones is for white. So as like initially we are creating a black image, so we are creating as np dot zeros. Now this is going to be our width and channel of our window, which we are going to the dimensions of our image which we are going to create. And then np dot uint 8 is just type of encoding. It is defining that we are having an integer, unassigned integer from 0 to 255. Yeah, so this is it. Now we are going to give the position like color to our image, that is which we initially called as img. Okay, just how do we know that this image which we created is actually black? So let's just first show this image to you. cv2 dot wait key, cv2 dot destroy all windows. So let's go, let's see what we get. See, this is the image. Yeah, this is the screen in which we now have this our track bars, but till now we are not getting our image window. So why is it so? Yes, as we already have made this track bar named window, so we'll be just, the name of it will also be the same, track bar. Yeah, now you can see that we can get our screen of black color, right? Now till now, like if we move even this thing, we won't get any color change or anything, because till now we have just defined our track bars and give it a position. We have saved these positions into a variable, we haven't changed anything. So now we are going to change. So as image is the array of pixels, so we are using here is slicing property of Python, using the semicolon and p comma g comma r. This will give the color. Okay, as we have copied pasted this, so we haven't changed these positions, due to which we are not getting any changes into our. So now we have created a track bar, we have initialized our main function, we are getting the track bar positions, we are giving these positions as an input into our image, and we are showing our image. So we are good to go. As you guys can see that by now changing to our bgr this track bars, we are getting the colors. So now you can even get the knowledge of the color by seeing this track, by changing this track bar, as this would help in our next project, as we are like closer to our final project, that's virtual background. So I am going to continue this save the project in this same file. So for this thing we have to give the maximum range and minimum range to our image OpenCV. So I am just copying this again and giving and pasting it. But now we are okay, it's like just capital B, small b, like, yeah, so it's upper B, upper G, upper R. Now this is lower B, lower G, lower R. And for this thing, as our lower value is going to start with 0, but our upper range, like upper values we are going to start with 255. So we are changing this, and now we are not going, we are having a pre-made image. So I am just even deleting this np.zeros, and I am loading it as im read. In this im read, we are going to have it as smarties.png. Now we are even going to have this as B, this as G, this is R. So now we are going to name it as LB, as we have already named. So L underscore B, L underscore G, L underscore R, and now it's U underscore B, U underscore G, U underscore R, so now we are till now. So now we are ready with our variables, and now we have to define it. So now we are going to have this array. So our lower bound is going to be L, and lower bound is going to be np.arrays of are all lower values. So that's L underscore B, comma L underscore G, comma L underscore R. And our upper values are going to be np.array U underscore B, U underscore G, U underscore R. Now we are going to use masking to define for this instance segmentation which we talked about earlier. This mask will help us to know where is the like object which we are searching, which we have searching for with this parameters. So that is mask is equals to cv2 dot bitwise cv2.bitwise. Now these takes arguments src1, src2. That is source 1 and source 2. So what are our source 1 and source 2? We are putting, like we are applying this mask in our image. So we are our first source is also image, and the second source is also image. Now mask is equals to cv2 dot in range. Sorry, now the mask is going to be cv2 dot in range, and this mask will like help us know where our concerned object is. So okay, cv2 dot in range function. Now what are the parameters it takes? It takes source and lower bound and upper bound. So what is our source? Our source is image. What is our lower bound? Lower bound is capital L underscore B, comma upper bound, that is capital U underscore B. Now we are going to have our results. What is our result? Res is equals to bitwise AND. Now as we go through bitwise operations in our like curriculum in our academics, what is the bitwise in this OpenCV? This bitwise in our OpenCV is like, consider you are having two images. This is image 1 and this is image 2. Now as I told you earlier that white color is bitwise 1, but its value is 1 and black is 0. So for bitwise AND, what is bitwise AND? Bitwise AND is if 1 and 0 meets, it becomes 0. 0 and 1 meets, it becomes 0. If only 1 and 1 meets, then it becomes 1. As you guys can see, we have all black and only a circle white, and in this we have half black and half white. So what we are getting in this right side half of it, as everything is 0, so whether it in image 2, whether it be 0 or 1, like whether it be black or white, it does the right side half is always going to be 0. That means it's always going to be black. Now in the left side half, what we have is we have a circle white. So only a part of circle will be white and else will be black. This is bitwise and for bitwise OR we have as white and black, 0 and 1 meets, it becomes 1, and or 1 or 0 meets, it becomes 1. Only 0 and 0 is black. So from all these examples you will get to you can get bitwise operations better. So now let's get back to our code. Yeah, so in this res bitwise we are going to have it as AND operation. Like you'll by after the result I'll explain why we are using this bitwise AND operation. cv2 dot bitwise and now what are the arguments it takes? It takes source 1, source 2, and what this DST, that's mask. So what is source 1? Source 1 is as we are applying, we want to apply this in our image. So this is image. Source 2 is also image because we are applying two image, and the third part is mask. So mask equals mask. Now this is our res. Now we have to show all these images, like all these frames which I have defined. So we are using image IM show. First is going to be image, img cv2 dot im show res, and the another window which we are going to have is cv2 dot im show now we are done with res image mask. Now as we don't need this image, so I am changing this. Now even as we don't need, we can even give this as a new name as track bar. So just change all these names. We even have to change these names in a track bar position. Till then, if anybody have any doubt, just let us know in our chat box. We'll get to your doubts. Yeah, I'm looking. No one. So yeah, so let's continue. We even have to change this names of UB, UG, UR, LB, LG and LR. So now we are done with this our project. Let's see what is the syntax error we are getting. Why so? Okay, yeah, we have initialized our array but haven't closed it. So yes, take care. So control S F5. We got, yeah, so it's like, let's see what happens. That's actually a same code, but like I guess there are some issues with my this current working window that I am. So yeah, so just a second. Yeah, so this code is this, that like now this is upper lower value of our b. So as you can, as you guys can just a sec. Guys, is it visible to everyone, like right now all four windows named image, res, mask and tracking? Yeah, so as you guys can see it. Yeah, so as we change this track bars, you guys can see that I am having even changing in our mask and in our res. So what is this doing? Yeah, so this, just change to it. Now what is actually this doing? We have in our code, in this code what we have defined is, we have defined a range which is governed by these track bars, lower range and upper range. Yeah, so if a color, if any of these color values of of this bgr, or like here it is hsv, so if these comes under these values, like if h comes under 95 to 230, yeah, so then the here in this mask it will become white, and only that will be shown here. As I told you that the whole image is actually white, and the thing which comes under this range is becomes white in our mask, so the rest becomes only the white and white of our mask and our original image. So by this you can like easily detect any particular color. It's like, see, right now I am just focusing on this brown color, if you guys can see, or let's take any a brighter color, that's blue. So it's like you guys can have just play it around with the track bars and get the range of every color which we can use. Yeah, see, now I have eliminated the blue and green color, and we are just left with red, or the like shades of red that's a bit light. So like you can even get it rectified, but like, yeah, so you get, see, this gets, so we'll not put much more time into it. So let's move on with our final project. So here we'll be using our video capture. So in this thing, I am, all this is defined for our, now we have just catered with images. Now what if we can even have our live video feeds using this OpenCV programs. So how to do that? We have to define a cap, like it's capture or anything. So that's cap is cv2 dot video capture, and the argument it takes is source. So it's 0 if you are using any, like your primary webcam of your laptop, or it's 1 and 2, like it depends upon your connected, how many cameras you have connected. So yeah, this is it. So now we have to get into that, get into our loop, and ret comma frame, like you can, here you can give any name to your video capture which you are naming. I am giving it as frame, that is cap dot read. Now what is ret is, ret is actually the return thing which we'll get, like it's a it's not like very prominent name, we can give it as any name, let it be underscore or ret, it won't change anything. As like if we go on further, you'll get to know that we are not even going to use it, so you can give any name to it. Now we have defined our frame, and now you can give any image which you want to use it as your background. So as we have defined image earlier, So I'm just going to use that, and instead of Smarties this time, let's have some, like, I have a picture of computer vision. Yeah, I have this computer vision in my same folder .jpg. So now we can control the all these, like, in range and all those stuffs. The thing is, the logic behind this program is, how will this CV2 will get to know that where is the our instance, or where is the object we are concerned about, and where is the background. So for that we are using this, we are like defining a location. So we are defining it as location, and from location we are getting as np dot where, np.where res equal 0. So we also see here we can also see that the our instance is like colored and every else thing is black. So we can just say that every other thing which is black, we can name it as our background, or we can replace it with our image. So that's our logic behind all these, behind this, like, program. So now while coding it is as in frame, where location, as we have location already defined, is as where res is equal to 0. So frame of location, the point is will be equal to image location. So the points where are black in frame is going to be image. And now we just need even to show res dot frame. So okay, so we got some error, too many indices for array in location thing. So let's resolve it. As it's like, as we are like, by defining it as array, we are giving three res points, that is bgr, to hold a where it expects a single value. So we are changing it, control s f5. Let's just clear some things. This is not responding right now. Just a second. It's really sorry, guys. It's just I'm having some. My Python is really not supporting today. Till then, guys, like it's not supporting right now. If you guys having any doubt, you can just ask regarding any of our initial projects also, or any of the concept. Okay, let's see if now it works or not. This is not working right till now. Yeah, so now guys, it's now working. So for to set your background according to you, you can just see. Yeah, so it's now a bit like you can tune it according to your convenience and get the desirable background. uh, yeah, like being this thing in white, so this actually gets eliminated. But yes, it you now you can see. Okay, there's some disturbances in my face. So guys, yes, like you can see that there are some disturbances, but still it's like close to it. My nose is getting a bit disturbed. But yes, okay, like just let me try if I can even get you, like, show you code of it. Due to all this non-responding thing, this is not required. Mm-mm. Yes, so now I have code of it. Just the frames also, if I can get. Yes, yes, guys. So like, is that what? As you guys can see, that what we have actually done is we have we have taken our instance, and that we can see in this in our mask thing as white, and the else everything is our background which comes here. See, it's like my nose here is bit black, so that's why it becomes just like as our background. All these disturbance you can get it, like we can even get it much more clearer by using some filters of OpenCV, but as it's already been 1 hour, so we can't continue with it. Like, we can even, you guys can tell us that we can even include it in our next series, next part of our this OpenCV, or else yes, we are with this final our project, we are done with this webinar. And to for further more for further more webinars, you can have, we have our feedback link in our descriptions. You can tell what are the topics you are interested in. Our team will work on it and present you that webinar if if that's feasible for us. You can follow ISTE VIT site, that it's these are its Instagram handles of ISTE VIT, Facebook handles, LinkedIn handles, and GitHub. You can get every resource of this webinar, every code in this repo. If you can find this in GitHub, ISTVIT's GitHub. And a bit about me, I am Jayesh Singh, and these are my GitHub profiles and LinkedIn. Thank you everyone if for to coming into our the webinar. Any other suggestions will be like welcome in our feedback form. Thank you. And if anybody have any suggestions till now, you can tell me. Yeah, so that's it. Thank you guys.